Um, Hello, everyone. Am I audible?
Yes, we can hear you.
Okay, thank you. Welcome, everyone, to our latest course from SkillSurf, conducted by the Department of Electronic and Telecommunication Engineering of the University of Mortar. So our latest course is on embedded product design, and we have been planning this course for quite a while now, and the whole idea of this course is to provide interested participants with comprehensive training in this area of embedded product design within an 8-week span. So yeah, let's get into this course and all the details and all the exciting things that we have in store for you. So first of all, I'd like to I'd like to cover the agenda for today. It will be starting with an address from the head of the Department of the Electronic and Telecommunication Engineering Department, Dr. Ranga Rodrigo, and followed up, there will be a keynote speech by Mr. Kosala Jayasundara, and then Dr. Subodha Charles will be covering the course intro and the logistics. So I'd like to warmly welcome Dr. Ranga Rodrigo, sir. Please take over for the address. Thank you.
Thank you very much, Kitmin. Thank you very much for joining from British Columbia. Can I be given the rights to share the screen? Yeah, I think I can. Yes. Yes. Also, I warmly welcome Mr. Kosala Jayasundara also. He's a very senior engineer who has vast amounts of experience in the product design for IoT and other electronic product design areas. And also Dr. Charles himself, who will be in charge of this course, is very well versed with embedded products with cyber security aspects in mind. So thank you very much for designing this course and launching. And I welcome all the participants who are here. Thank you very much for placing your trust in this program. So the purpose of the program will be explained by Dr. Subodha Charles, but I'll briefly talk about the electronics department and what it means for us to offer this program to you. See, when you think about IoT devices, now these are little devices that are able to be connected among each other and connected to a network. And they may sense something, they may do some processing and communicate. So you can see in the world, so many such devices are now deployed. Maybe even the machines that you buy at your home are IoT devices. So if you think about the computers, the numbers are quite less compared to the massive number of devices that will be displayed, disbursed. So therefore, it is very important for us to understand and to be able to design these devices. Now, for example, these devices usually run on battery power. So what is the importance of conserving power? What is the importance of having a unified view of all the devices that have been deployed? What is the role of software in this case that run inside the device? Also, the software that gets a federated view of all these devices. So these are the things that are important to us that we will communicate to you in this course. So as a department, as you know, the premier department for electronic and telecommunication engineering in the region, we think that we must share knowledge. So as a university, actually, we stand for preserving knowledge. That means we have a repository of knowledge and we create knowledge through our research, and we want to share our knowledge among the public also. You know, we can only take 100 electronic students and 15 biomedical students to our university because of the limited number of seats and laboratories that we have. But we want to make our knowledge available to others also. That's the main purpose of designing this program. So we have many staff members, we have many laboratories, and I think you will get a chance to come to the department and see them also. So these are some degree programs that we have. We have MSc degree programs that are taught programs, and then of course research degree programs, MPhil and PhD degrees. So there have been so many success stories in the past. In 2009, we won the World Championship in the IEEE Extreme Programming Competition, which is a large programming competition with 700 teams from 40 countries. And there have been many success stories, and I will just concentrate on some we achieved a couple of years ago, 2021 World Championship in the IEEE Signal Processing Cup. And this one also was designed using an embedded system. Yeah, so 2021 World Championship in IEEE ICS, and then top publications in journals and conferences. This one is also a robotics championship. So you can see this is the first place that we won in Thailand for a robotics project. You see, all these devices have embedded systems. These embedded systems communicate within the device and with many other devices outside. So, so if you take this project, for example, now they had a ground robot and they had an aerial robot, unmanned aerial vehicle. So there was communication between these devices. And similarly, we want to communicate between many devices. So we have strong expertise in this area. That expertise we want to display to you. So there have been many other success stories also. So using FPGAs, if you want large amount of processing, I mean, it is much more complicated than the processor that you would have in an embedded system. So we have expertise in that area. So these people won the championship in Japan and Asia Pacific and won the world silver medal in the world arena. So you can see some students here, they after graduation, they went to Harvard University to continue their research work. So actually, Kitmini talked to me last night over email and said that she will be joining Berkeley for the bioinformatics area, computational biology area. So you can see our students have performed extremely well. So there are things that we can offer you also, so that you can also associate with us and see how we think about education, how education is transferred. So you will see the project-based aspects in this program, as Dr. Charles would mention, outcome-based aspects. That means after you do the program, you will get something out of it that you can use. So good publications in journals and conferences. So we have a serious expertise in computer vision and artificial intelligence also. So you can see one of my last year students, Mohammed Affam, posing with Jan Likan. He's the chief scientist at FAIR, the Meta's, Facebook's artificial intelligence research organization. Yeah, so we have many staff members, including the chancellor, and I'm also here. So then you will be, Dr. Subodha Charles is managing this program, so he will talk to you later. So actually, to briefly talk about Dr. Charles was also studied in our department at Moroto University. So while he was studying, he was very much connected with the IEEE, Institute of Electrical and Electronic Engineers in the US. So he did many engineering projects, and he was connected with the international community of engineers through this organization. Even now, actually recently he came back after a meeting in the US with these people. And then he went to do his higher studies in the University of Florida in the US. So there he studied about embedded systems and cybersecurity within those systems. And that's why he has serious expertise in this area. So whatever the question that you have, whatever the even research-oriented questions that you have, you can ask from Dr. Charles and he'd be happy to answer. So we, under Dr. Charles' guidance, we have lined up many resources for you. I think Dr. Charles will introduce these people to you. So if you think about the qualifications that our staff members have, they have PhDs mainly from Canada and North America, and then the Europe, then Japan, Australia, and so on. So we have a lot of qualified people in our department. Yeah, so I want to show you some robotics projects that we have done. These are very close to me because some of them I also contributed in supervising. So this was supervised by Dr. Peshal. You can see it's a rough terrain robot. This is also a rough terrain robot. You can see the same robot climbing different kinds of terrain in the other video. This is also a very exciting project. There you can see we designed a carom playing robot. So you can see it places the disc and precisely executes a shot so that the pieces go and get potted. Yeah, and many other projects, our deep learning work for autonomous driving, our camera design work, and then this is the pioneering unmanned aerial vehicles, the drones work. So Professor Rohan Munisinghe pioneered that in our country. So many drones are there in the department. Maybe when you come, if you want, we can arrange for you to be able to see those drones done long time ago and the current drones that we have. And this is also an interesting project. You can see this is a collaborative robotics project. There are 3 robots here, 2 moving robots and the robotics arm. So a camera looks at all these robots, and then what happens is we give a plan for the robots to build a building. So you can think about these little things as bricks, and the robots move them, automatically understand how to do the building through some mechanism called reinforcement learning, and then they make the building. So very exciting project there also. So like this, students engage with so many exciting and novel projects. And we want to make that knowledge also available to you, that experience available to you. That's why we design these programs. I know there can be many courses online in these MOOCs like Kosala, Udemy, and so on. But I think we have a unique experience to make available for you and give you the practical exposure for this. Yeah, that's why we are here. So just to briefly tell you again, we want to create knowledge through our research work. We preserve knowledge in our lecture notes and other repositories, and then that knowledge we want to share with you. That's the purpose of organizing this program. So you are most welcome to contact me at any time, ranga@um.lk, and you can see our webpage here, the Facebook page, and the YouTube channels. Actually, the YouTube channel has videos of the final year projects. So you can see how these concepts that you will see in this course have been practically implemented. So once again, I respectfully thank all the lecturers who would be teaching you, including Mr. Kitmin, who took a lot of effort in organizing this and curating this program. And then Dr. Charles himself, who's in charge of the program, and Mr. Kosala Jayasundara, who's addressing you as the keynote speaker today. And I welcome you once again. Thank you for placing your trust on us, and we will deliver what we promised. Thank you very much, Kitmin.
Thank you very much, sir, for the great overview of the department and what we do. Thank you for your guidance as always. So yes, I think after that great address, we are ready to go into the keynote speech. And we have Mr. Kosala Jayasundara, as sir mentioned, alumni, a very experienced alumni of our department. Kosala, I think you can take over now. Can you share the screen?
Yes.
Okay. Great.
Hope you can hear me. Thanks a lot for inviting me to the keynote speech and the opportunity. I really am interested and excited to share this keynote speech with you and to be part of what we are delivering. And this is, I think, a very good initiative from University of Moratuwa because this is something we should do for our industry, our people, individual, and the people who are actually interested in coming to the electronic industry. As Dr. Ranga mentioned, we should not only focus on our university and the only 120 people that we can recruit every year, but we have to make sure that the knowledge flows through all levels of our country so that we can grow as a country and develop our industry. So that's something I wanted to focus on my keynote speech also, how we can, as a country, as a team, build this technology and know-how and go forward with that. So thank you very much again for inviting me for this. Just to introduce a bit about myself, I was graduating from University of Moratuwa in 2004 and worked as a lecturer for some time. And then I had quite a bit of startups. I started High Tech Solutions in 2004 and that for 10 years. joined MAs for wearable tech and IoT divisions for 6 years there. And I again started Excel Automation, Electron in 2020, and now I'm running Excel Tech, which is now registered as an Estonian company and Sri Lankan company both. So this is a kind of a brief journey I had. But just from the graduation, I worked in electronic product development and automation for many years. So I have a bit of experience to share. And currently I'm having a few contributions in SLIT and Jaipur University, also in Senate. And our current area of focus for my company is in medical, wearable and IoT to develop these products to North American and European market. Just to give you a few examples, what I can share, there are some other products that I couldn't share in open forum. So most of the products that we develop are certified for these markets, especially including the two first devices in the left top corner. These are medical electronic products that should be certified for FPGA class 2 because they are used in the hospitals and therapeutic sessions. And sometimes I'm doing a lot of marine products, marine and subsea for oil rigs, ships and everything. Those are sometimes certified for marine applications. And in the bottom left corner, we have another product that we are developing for heat therapy, heat and light therapy. Again, this is for FDA class 2 certified. And top right corner, I have products which are actually related to IoT, which I could show. These are devices that are connected to the cloud, and multiple devices are communicating to each other, especially the smart garment, it's connected to VR, and multiple devices connect in the real time with the minimum delay possible. So these products, most of them are already launched in the market and some are in the process of launching. And we do this kind of products not focusing on the complexity of the device, but the actual usage of the device, how we can produce and manufacture and sell at a profit. That's the main idea when we are in the industry. And also there are a large amount of certification and testing we must conduct so that we can sell that in the North American market. So this is what we are not focusing in our company. And just to introduce you a bit about what we are talking about in this product development, it's not only prototyping. As you can see in the diagram, there's a part for prototyping, design and prototyping, but it's not the whole product development process. The product development process should start from a customer need or consumer need, and then market analysis, and then business requirement document to make sure that we are going with the correct requirement, and then designing a prototype, which is something we normally focus. Normally, we are very good in electronic. I know as almost everyone who have joined here have a good electronic background, and they know how to do design and prototyping, and they can do it really well. But we have to focus on holistic view, how we can make a marketable product that we can manufacture in bulk at the economical price. This is very important, and we'll focus this also in our course, not just to prototype and like show it in exhibition, but to make sure that we develop a product which can be marketed and sold in the competitive market. So the bottom picture is about the design process that we follow in our company, but it doesn't mean that you have to follow that. But it has a large amount of different steps when we are in this process, and development, prototyping and development is only one part of it. And this development process, it's a very complex equation of all the different aspects, not only design. So if you think about running a company or running a product development and manufacturing firm, then there are a large amount of different parts involved in this process: finance, marketing, logistics, fulfillment, manufacturing, compliance, testing, operation, and design. So it's not only one aspect that makes a product successful. if you want to actually put something into the market and make sure that it's successful, you have to make sure that your organization, if that is a company, university, or whatever it is, has all these aspects aligned correctly. For an example, you might have a really good product, but if you don't have enough finance to go to the bulk manufacturing and do the marketing, then your product may fail. And if you are really having a good product, but if your marketing aspect is lower, you can't find the correct market and show the product to the correct market. Likewise, all these things should be properly thought through before we actually design our product and launch our product to the market. So we have to make sure that all these factors are combined successfully and reliably to make sure that we succeed out in the correct market. I have a bit of a product development YouTube series I designed in, I think, 2020. I failed to add a little more detail to that, but still it has around 17 different videos about product development, so you can go and see it if you wish so. And about let me share a small story about IoT and who is actually winning in IoT. Currently, China is smashed in the market, mainly because of a few reasons. Let me talk about it, because it's really important for you to understand what China does for the IoT and how we can replicate that, or how we can do better. So this is a story that we have to learn in depth. It's really deep how they have done it, but still, just as an introduction, they have done a really good ecosystem. As I previously mentioned, a product should have large amount of different aspects connected, and China was successful in connecting them really well. It's not only they are doing it bulk or having cheaper labor. It's not the case. Especially in IoT, it's not bulk. China is doing bulk manufacturing, but they are not doing it in millions. If you go to their products and see how many products they manufacture, that's not many bulks. That may be in thousands, but not in millions. And their labor is not cheap. But they have a proper ecosystem which is really optimized. That's what actually drives the success in China. For an example, I have one company. I can show it to you. Can you see it?
We can only see the screen right now.
Okay, just give a second. Hope you can see it now.
Yes.
Yeah. So this is a company which is manufacturing IoT device, specifically IoT device, mainly home appliances, but they have other security, smart, all other things. But if you can look at all the product portfolio they have, they are simple devices, but they are really beautiful, elegant, matches the user requirement, and they have all the aspects that a normal user would like to have. They might not be reliable. That means it might not last for 10 years, but they will comfortably run for 2-3 years. And then they have a large amount of portfolio, good marketing, and their manufacturing base is really good. They have a really, China as a country has a good logistic network, and their components or the circuits, PCBs, casing, everything is really low cost, because all these components are also very much optimized. So they have a really nice ecosystem, marketing environment, Alibaba and other platforms that they can sell. So everything together has made China successful. It's not the bulk, not the low cost labor. Normally, Shenzhen, where they manufacture most of the devices, their salaries at least 5 times higher than our salary, but still the product is much cheaper. This is something we have to focus and copy to make ourselves successful. It's not just the prototype, it's the combination of everything. And again, the second point is that being IoT manufacturer or IoT brand is, on my opinion, hard. Not because IoT product development is hard. We are teaching them it really well. And I know you have a good idea about electronics. But it's a complex market to be successful, because IoT products are not really extremely expensive. The product line that I normally manufacture, these medical products, those products can be sold at very high prices. But IoT, the price so is really critical. We have to compete with China. If you want to sell it in the open market, you have to make sure that the few cents in USD are critical and you are saving that amount and competing with the price with Chinese products, because Chinese products are not bad. They are really good. They are really nice. Outlooks are very good. Molding is really nice. So you have to make sure that we compete in the correct way. But there's a nice opportunity, and I really like that University of Monaco is conducting this course at this time of the world, because global trends are changing, and so much of statistics are changing, because China is not growing anymore. It was growing for the last maybe 20 years real rapidly in electronics especially, but China is not growing, and the other countries like North America, Europe, they are not willing to purchase Chinese products anymore because of these global politics and everything. And there's a huge gap created for products that is not manufactured in China. But there are not enough manufacturing facilities outside China that can cater this market. There are a lot of countries like Thailand, Vietnam, Taiwan, Indonesia, Malaysia, all these, and India, of course. All these countries are gaining momentum, but still is not enough. At least for the next 10 years, those countries won't be able to totally replicate China. So there's a gap that customers need non-Chinese products, but there are not enough countries to manufacture that. So Sri Lanka has a really good opportunity to become part of that manufacturing shift. One positive we have is Sri Lanka has good reputation for better quality, higher IQ, lower salary scales, and also reliability. Like people in Sri Lanka are not labeled as liars or opportunities. So Sri Lankan industry has a better reputation than most of the other countries in terms of reliability of the products. Especially, we have built up our name in terms of software and firmware industries, and we can continue on that advantage. But only issue is that we don't have the proper infrastructure and knowledge base to build on that market opportunity. So that's why I said I'm really happy that University of Monaco is conducting this course at the correct time. If we have this skill, building up opportunities is really easy, because now there's a gap created and we can cater to that gap. Previously, 5 years back, even if we supplied Sri Lankan made products, there's no special demand for that. But now that there is one. And just to show you how much opportunity you have, IoT opportunity, especially in IoT, I have never seen an industry which is growing for so long. Like the statistic is from 2013, and until this point, there's a really rapid growth, probably 20-30% increase year on year, which is really high. So from 2013 to 2014, the IoT market grew from 6,000 to 10,000 USD millions. So likewise, the growth is continuing. Until last year, China was catering this growth. That means Chinese IoT industry was growing at this rate and fueled the catering, fueled the IoT market. But now the China is not growing anymore, and people in other countries want to buy from China. So this growth should be fueled from other sources. That's why there's a huge business opportunity. And even in the predictions, in almost all the predictions from different statistical organizations, they say that the market will continue to grow at a probably 22% rate for the next 10 years, which is normally unheard for in most of these electronic applications. If you think about medical electronics and normal consumer electronics, the devices like fridges, ACs, the electronics there, and maybe military applications, they are not growing at this rate. They are probably growing at 2, 3, 4, 5, that kind of percentage. And seeing a growth which is running for 20 years at 20% rate is unheard of. So IoT is a really good business, on my opinion, to be, because of this growth rate in one aspect. The other aspect is that the manufacturer who was fueling the growth rate is not available anymore. So it's a good opportunity. And there are a large amount of new resources required for this kind of growth. Like when we are developing IoT, it has unlike other products. Say if you think about a controller in a fridge or washing machine, it's a single board and it controls the machine. That's it. So you need only firmware designer and hardware designer as the engineering team. But when we are developing IoT, the region is much more wider. So you need large amount of different expertise to build a IoT infrastructure. So there are really good salaries available, especially for full stack developers. And the salaries are extremely competitive and maybe even comparable with the software industry in Sri Lanka. So if you see what kind of people are needed, especially in engineering, I'm not talking about all the other aspects like logistics, marketing, finance, fulfillment, all these expertise are also needed. But if you talk about only the engineering, we need hardware designers who can design good electronics at competitive prices and reliability needed for IoT, which is hard. It might be even harder than developing a really reliable medical kind of application. If you go to medical or military, the design is complex, but it's not hard. The reason is they have more than enough money. You can sell a missile to multiple millions, but IoT has maybe a few cents of margin. So designing hardware that's optimized, reliable at that kind of price point is hard, and you have to learn it properly. So the hardware designers should have different expertise on that. Again, firmware development is needed for all these IoT, for data communication, Bluetooth, Wi-Fi, everything. And then most of these devices are connected to the power grid, and these devices need certification. You need CE for Europe, FCC for wireless communication, and UL for US market. Likewise, you need people who can do certification. And there's nice mechanical design. Almost all these IoT devices should look good. Like if you are putting it in a switch gear or a plug point or something like that, it should look really good. And China has nailed it really well. Like their product visual quality is really good, and they are doing it well optimized. So the material usage is lesser, reliability is good, look is good. They have good molding facilities. Likewise, you have to have good mechanical designers who can develop the designs well. And then after we produce that product, you need a lot of other resources, like you need the mobile apps, and then you need app developers to connect to that apps, and then front-end and back-end developers who can put up that data in the cloud and show that aggregates in the cloud and show the graphs, trends, and everything. And then for almost all the IoTs now in the new market, we have big data analysis and usage of AI. So that part is also there with the backend. So we have a large amount of data collected from these devices. And then we need people who can analyze the big data, do the predictions, and connect with AI. So there's a large amount of resources needed, engineering resources needed for this kind of development. And it's good because we have more than enough opportunities if we can build this as a business. So within this course, Dr. Subodha will explain you in detail, but just to give a glimpse of it, we are trying to follow a structured approach in electronic product development within this course, not just to do a prototype, but a proper development procedure and make sure that it's a marketable product. It has the case in features and everything. And we are doing an actual IoT product development, not a prototype, something we can actually put into the market so that you can learn all these aspects in the product development, prototyping, putting it the case in all the things that you actually want to learn if you want to put something into the market. So you can put it as a model product from end to end. And then we are working with business requirement documents, product development process, and everything that makes sure you are developing into the correct consumer market and how to get that consumer need and everything. And including resources. So you can, within this course, you can get all the resources needed for this kind of development. So I'm really excited, and see that how you would learn on this course. And I'm really appreciative about the University of Moratu about conducting this course. And my contact information is there. Let me know if you need anything, any more information. I'm more than happy to assist you and share my knowledge on this. Thank you very much.
Thank you very much, Kosala, for that excellent introduction into product design. And we're really glad to have you on board as well. I know you will be doing a session next week for the registered participants. And those who want to learn a little more about this area, I think he is arranging a much in-depth session next week.
So Kitmin, I also personally want to thank Mr. Kosala Jayasundara for this extremely insightful talk. I also learned a lot. Thank you very much. Thank you so very much for providing me expertise.
Yes, sir.
Thank you so much, sir. Okay, I think we can move ahead. So finally, we are able to go into the course introduction and to deliver all the details and also conduct the Q&A at the end of the session. Dr. Subodha Charles, you can take over now.
Thank
Please
you,
let me know if
Kitmin.
you can share the screen. Thank you.
Sure. Yes, I can. I think I have a different Zoom background. Let me quickly get the one that we have for this course. It's ENTC. It matches, but not exactly the one we are looking for. Okay, better. Thank you, Kitmin. And thank you to Dr. Ranga and Mr. Kosala as well for delivering the previous addresses. So what I'll try to do is, I'll try to give a brief overview of what everyone here will be going through when we start the course within the next 16 weeks. I'll share my screen. All right. Now, starting from where Mr. Kosala left off in his keynote speech, you might have seen in many places, like you take exhibitions, there are a lot of innovations coming out of Sri Lanka. People do a lot of things. They learn things either from university or they teach themselves, and they come up with very good innovations. The challenge that you're facing as a country is that how many of those new creations, they don't actually come to market. So that is a challenge that we have faced, because eventually we need to contribute to our economy through the creations that we are making. And that has been lacking in our country, which is why we thought, okay, we know how to do things, but do we actually know how to build a product that is marketable and that can be sustained in the market? Are we addressing a requirement? Did we do the due diligence, doing the feasibility, the market analysis, and then taking the product into the product development life cycle that Mr. Kosala was talking about, and we'll talk about those in detail in the next upcoming weeks as well. So that was the main motivation behind developing this course, Embedded Product Design for IoT. As you can see in the title itself, we added the two words, product design. So we start from the prototype, of course, but then we go the end-to-end process. So when I go through the 16 days, the schedule that we have, you will realize that we cover all the skills that you need in terms of programming, in terms of PCB design, enclosure design, because sometimes even when we do a project in the university, the students are good at programming, then we do the PCB, we put things together, but the outcome doesn't look like a product. It is working, it's a prototype, a proof of concept in most cases. So we added the enclosure design aspect also, because if you have a product idea, having that end-to-end understanding is good. Right? So that was the motivation for us. I'll give you more details about that, but let's first look into a few things. I'm gonna skip this slide. So now the course is about embedded product design, right? So when we come to embedded product design, we need to first understand what an embedded system is. So this, I think, is pretty straightforward. You know what this is. You have used an embedded system for sure in your life. Even if you take a mobile device, that is actually one embedded system example. So no matter where you look these days, you have examples of embedded systems, whether it's automobile, medical, entertainment, home automation. As you can see, there are many examples in the slide here. Now, early days, when first computing came into the picture, it was something that looked like a very huge machine. But now we are developing smaller and smaller devices to cater to different requirements that we have. When you look at the large domain of embedded system, we can break it down into several subcomponents. So even here, the subcomponents, they are very high-level overviews. So what I mean by that is, you can zoom into these different areas and gain knowledge about very niche areas. Here I'm showing embedded hardware computer architecture, but even to develop like a processor, about 100 or even more engineers get together. The process is huge, but at a very high level, we can look at these categorizations when it comes to embedded systems. And the first one being embedded hardware. And then we have the software side of things. Then you need to communicate, especially in IoT, these connected devices will talk to each other, will send data to the cloud, and that comes as a part of the communication infrastructure as well. Then finally, the enclosure design, because to develop a product, you need to make sure it looks good. So nobody likes to wear something that looks bad. That also comes into the picture. Right, so a combination of all these things make an embedded system possible. And when you look at the people, sorry, not the people, when you look at the companies in the global embedded systems market, it's a multi-billion-dollar industry. There are many well-known companies in this embedded systems market. Obviously, you have seen these logos, you have seen these companies. Recently, NVIDIA hit $1 trillion in market cap, especially with this emergence of AI and specific hardware that are needed to run these AI models. So these companies are getting a lot of traction. When Mr. Kosala was delivering his keynote, you saw the growth of IoT. And one of the very few areas in the world that has kept growing. And you can see the growth is exponential. It's not linear, it's exponential. So that speaks to the potential that the domain has. And with the whole geopolitical things going on in the world, if we can capture at least a small portion of that market share, because right now in Sri Lanka, these data I got from the Export Development Board, our market share is very small. This is electrical and electronic combined. But if we are to make a dent in the economy, like to make a real impact in the economy, we need people with the skills. And looking ahead, because the current economic situation that the country is going through, if we can come into the product development market, that has a huge advantage. Because right now, when you look at the priorities of Sri Lanka, most of the exports happen through the services industry, or things like tea, rubber, and apparel. But when you compare the Sri Lankan scenario, that is the product and the services sectors, you can see the gap is very small. But you take a country like Singapore, you can see it's more than double. You take Thailand, you take China, see it's 10 times. So we need to be able to come to a point where we capture the value from this supply chain, so that we can effectively contribute to the Sri Lankan economy as well. So in the right hand side, at the bottom over here, you can see the consumer electronics industry is generating a revenue of this much. Right? These are in billions of dollars. If we can capture 0.1% of it, not much, 0.1, see the contribution that we can make. You take 0.01, even that is okay. Even that is more than the current capabilities that we are having, right? So this is the problem that we need to address. This cannot be achieved by the 100 odd graduates coming into the University of Moratuwa alone. They will contribute, of course, but we need more and more people entering this domain, getting the skills, coming up with their own companies, or else contribute to an existing company. Either way is fine, but eventually we will get benefited. The person will get benefited, the country will get benefited, as academics and as the leading engineering college in the country, we can think that we have also contributed to this course. This is our priority. I hope why we are doing these courses is clear to you. Having said that, let's move on to what I started before. I first wanted to differentiate embedded systems with what you already know. Of course, some of you here, you might know what embedded systems are. You are well versed. But if I am to quickly draw a comparison between the general purpose computing domain, which is your laptop, and even a mobile phone now can be known as a general purpose computing device because you can run thousands of applications in that. You compare the general purpose computing domain with embedded system, you can see a few differences. First of all, the main thing here is the general purpose computing, it is designed to run a broad class of applications. And some applications you don't know even during the design time of that system. Compared to that, an embedded system runs a single or a few specialized applications. That is the main difference. So I'm not going to run through the entire table. These things are obvious to you. For example, the general purpose computer is programmable. It has high flexibility. We can run a heavy operating system. Compared to that, embedded systems, they are not typically programmable. You deploy it and that's it. Right now with IoT, we are trying to change this because IoT devices has to last for a long time. Therefore, we are talking about things like over-the-air updates, making things reconfigurable. Now the domain is advancing. But in a general overview, you can think of these differences when you compare general purpose versus embedded. When you look at an embedded system, a complex embedded system, here I'm taking an example from an automobile, from a car. It is not one system. It is a combination of thousands of systems doing their own task and then combining so that we can deliver the output of this big system as well. So if you, of course, when we are starting, if we start with something this complex, it is going to be very hard for us to comprehend. So therefore, let me simplify things. You can think of any embedded system as something that senses the environment. If required, we will be converting the analog input into digital. Once we do the conversion, we can capture those information through an embedded computing platform. We capture the information, we process them, and then we make some decisions based out of them. The decisions get converted into an output that you display, or else you drive some actuator that impacts the environment back. So you can see it's a full cycle. We sense the environment, we do some processing, we make decisions, and then we make some change back in the environment. Having this simplified view in mind, in this course, what we are going to do is we are going to teach the concepts through a project. So this is the outcome-oriented nature that Dr. Ranga was talking about. We will go through the embedded product development life cycle by taking a smart plug, a smart power monitor as an example. So you can see even in the smart power monitor, it allows you to control the plugged-in appliance. This is the actuation part. And how do we do that? We do that by measuring the power usage, figuring out how much power this device is consuming at different times of the day, and how can we optimize. That is our decision-making process. Can we optimize? Can we turn on or off our appliance in an automated way? And given that this smart power monitor is Wi-Fi connected, you can even be at your office and turning this electric load on and off. That is possible. Maybe you woke up and you got late, you rushed, so therefore you could not turn off your AC. The same thing can happen at your office. You are the last person to leave the office. You are supposed to turn your AC off, but you were in a rush and you forgot. But if the smart capabilities are there, it's only a matter of accessing your device through a mobile application. So that is what we will achieve through the smart power monitor. So we sense the environment, we look at the power consumption in order to figure out how much power the appliance is consuming. That can influence our decision about when to turn the device on and off. Because you would like to save power as well, right? That is another intention that we have, another use case that you can use the power monitor for. I hope the scope of the project is clear. We'll go into a little bit more detail in the next few slides. Now you know what embedded systems are, how the simplified block diagram, and how we are going to develop the project based on that simplified view of the world, where we sense and we make changes back on the environment. So how are we going to give this knowledge to you? That is what I wanted to cover in the remaining part of this particular presentation. Before going there, I also wanted the entire course team, we wanted to get an idea about the audience as well. So therefore, if everyone can please go to this website and then add this code, we have a few questions that we wanted to ask from you to get an idea about. Otherwise, it's only us talking. We'll keep on talking. You'll keep on listening. You might even get bored. So let's turn the tables a little bit. Let's get some inputs from you. So please go to menti.com and add in the code. I'm going to shift to my browser. So please bear with me for a few seconds. So in the meantime, you can go to menti.com. I will send that number in the chat also. It's 5810. Send to everyone. 5810-5846. They are on the chat as well. You can go there. Let me start the presentation. Then, if you use your mobile phone to do that, on your mobile phone screen, you will be able to see the questions coming up, and then you can answer those. It's pretty straightforward, nothing very complex. We just need to get some feedback from you about the things that you have done so far. Okay, so if you log in, you will be able to see the first question. Let me share my screen and show that to you. The same question should appear on your mobile phone as well. Okay, people are already taking part. Nice. So the question is, which technologies are you familiar with? We listed a few things to get an idea about our audience. Let's keep the answers coming. So there are 28 people who have answered so far. In the call, we have 76. So I'll wait for a while for others to join and give the answer. While the answers are coming in, Kitmin, is my video clear and my voice is audible clearly without any issues?
Yes, yeah, there haven't been any issues so far.
Okay, perfect. Thank you. Right, we have 43 people. Right, I think we got a good sample size. Only one person is said none of these, meaning that the person is not familiar with either one of these technologies. Well, only one out of 70 something, that's promising. 38 out of 46 people, they have some knowledge about Arduino. So the basic stuff you have covered, that's good. Yes, we added JavaScript also to see, because sometimes you guys might be like software developers coming in to join to experience electronics. You might be getting started, which is why we added this. So we have a good idea about the audience now. Okay, I have a couple of other questions also related. Let's move on to the next one. So earlier we looked at languages and what you have done. So now at a high level, what are the skills? Because some of these skills are important in our course as well. Have you done any of the following? Have you done microcontroller programming? Have you done PCB design, soldering, and web development? Oh, and by the way, we will be doing some web development also in this course. Not exactly the web application development, but we'll have a online platform called Node-RED, which will include a little bit of JavaScript, but we'll teach you. If you are very new to that, we have that component also. Because if you're developing a product, eventually the user has to interact with it. And that is where the web dashboard comes into the picture. So we'll cover that content as well. Okay. So all these 4 aspects, microcontroller programming, PCB design, soldering, and web development will be covered in this course related to the project. Of course, the smart power monitor will teach you the necessary skills. So we wanted to get an idea about what you guys have done already. Okay. I think we got 44 people. That's like 2/3 of the people here. We'll move on. Please keep the responses coming. Okay, since I already gave the answers, I wanted to engage you guys, but we took a bit of time to get answers to the questions. So therefore, I'm going to skip this slide. What are some examples of embedded systems? If you type in something, we'll be able to see that coming in as a word cloud. But in the interest of time, since it's very straightforward, I'm going to skip this. Coming to the next question, these are some of the tools that we will touch on. Are you familiar with any one of these? Can you let us know? "30 people answered so far. We got about 45 responses, so I'll wait for the others to answer as well. Okay. So I'm glad that nobody said none of these. Right, I'll tell you why I'm glad about that. Let's move on to the next one. So the next opportunity is for you. Okay, so while I'm doing the presentation, even from what Dr. Ranga mentioned, from Mr. Kosala mentioned, if you have any questions, you can submit them through here. So we'll come back to this, but let me go back to the slides for now. You can either use the Zoom chat, we'll monitor that and we'll answer any questions. The Zoom chat comes with your name, but if you would like to remain anonymous for whatever reason, you can use Mentimeter and send the questions also, right? So you have multiple options. You can use Mentimeter, you can use Zoom, or else you can even unmute and speak. That would be nice. Then we can have a conversation, right? Hope it's clear. So this, I'll keep the presentation open. Any questions, you can drop that to Mentimeter or else use the Zoom chat. Let me shift back to the slides. Right, hope you can again see the slides and not the browser. Let me know if that is not the case. Thank you. Okay, so thank you for everyone who took part in the survey. Let's call it a survey, and gave us some information about what you guys already know. Thank you for that. That helps us get an understanding about the audience as well. Let's move on to the course outline. Okay. So this is what we are going to cover during the 16 days that we are going to have the course. So right now you are in day number 1. This is what we are covering. Day 2 will be starting with the introduction to product design and prototyping for IoT products. Let me go into detail about each and every one of these days, but at a very high level, this is the structure that we are going to follow. So we are starting today, 4th of June, and we expect to complete everything by the end of August. You can see in between this schedule, there are some buffer weeks. Okay, why do we have buffer weeks? That is because we give you some things to do, and then we give you time to complete them. If we, because depending on the complexity of the task, or depending on how much time it is going to consume for you to complete those things, we have allocated a few buffer weeks here and there so that you can work on that for about 2 weeks and then come back to the class so that we can have a discussion. There are some design reviews also. That means that you do something, you bring the design back to us, we give some feedback for you, and then we can work on refining that together. Okay, so let's see how we are going to achieve that. Everything that we cover in this course, it will be centered around this main course project. It will be centered around the smart power monitor. And we understand that if we ask each and every one of you to build a smart power monitor, that can be challenging. Therefore, what we are going to do is we are going to let you guys work in a group. Okay, so the project will be done in groups of 4 or 5 participants. That of course depends on how many people will enroll in the course. If you get more people, then we will need like a higher number of people in a group. Because right now we have actually ordered equipment. We can develop maximum 30 devices. That means if 120 people enroll in the course, we can cater to that. Okay, 120 to 150. It might not come up to that level, but we'll see. Right. So you tell us who the group members are going to be. We are not going to do that because you might have friends joining with you, so it might be convenient for you to join. But if somebody is struggling to find a group, then of course we will help. Right. So the course project will be developed in groups. It will be the smart power monitor. We will enable some user inputs through the smart monitor. We will be sensing through sensors, through external sensors, as well as the built-in sensors of ESP32. So this is the computing platform we are going to use. We will monitor the results of this power monitor through a web dashboard, and we will have some indicators as well, like LEDs and buzzers. This smart power monitor will be Wi-Fi enabled. So therefore, that means you can have two-way communication with the cloud. We will be able to do remote switching. The example that I took, you came out of office, you forgot to turn something off, you can do that through your mobile application. We can set up schedules, meaning that you can say that, okay, my air conditioner should run from 8 in the morning until 5 p.m. And after that, it should automatically turn off. So those kind of capabilities are there. We will be able to monitor the power consumption and some other electrical parameters as well, like voltage, current, active power, these things. And this can help. The why? That is because in addition to this manual turning on and off and the timers, you can actually gather the data and even develop a machine learning model based on this, so that the smart power monitor can understand the behavior of the user. Understand the behavior of the user without you explicitly telling it what to do. Right? So understand the behavior of the user and then control things automatically. That can be an enhancement that you will do. So the machine learning model is beyond the scope of this course. We are not going to go into that machine learning part. But by the way, as ENTC and also through the collaboration of ENTC and SkillServe, we delivered a course that was end of last year on embedded machine learning. So if you took the course, this can be an ideal fit. Maybe you might even end up deploying an optimized machine learning model into this hardware device as well, right? But that is another aspect of it. The reason why we added the monitoring capabilities is that you can enhance, going beyond the simple monitoring aspect. But of course, you can, without any machine learning, the monitoring aspect can be helpful also, right? Because when you get the monthly electricity bill for your home or for your office, you have no idea about how much units your refrigerator or your air conditioner consumed. You get one number. But through the capabilities of the power monitor, you will be able to say exactly, okay, my air conditioner consumed this many units and everything else consumed the other number of units. If you have multiple power monitors, then each one of those loads, you can say precisely how many units per month it consumed. Maybe once you know that, and you can set up a schedule, you will realize that, oh my God, I'm using so much electricity. So therefore I should optimize my air conditioner usage. Maybe I can add a timer and then make the air conditioner turn off at certain times so that I can save power. So all these intelligent decision making you can do by monitoring, even if you forget about the machine learning part of things. So this is what you're going to build. the smart power monitor. If you have any questions, as I mentioned before, you can either use Mentimeter or else you can drop them in the chat. So I'm getting questions through Zoom, which I will answer at the end of this so that I can gather everything and answer at once. I hope that is okay. Now you have an idea about what the project is going to be. How are we going to give the knowledge to you? As I mentioned before, the content that we will be covering will be centered around the power monitor. So from day 2 onwards, which is next week, we will start looking at the product development life cycle. Okay, so this will be like the big picture will be delivered by Mr. Kosala. So a brief summary of the content from next week was covered today during the keynote, but we will go into details. This is the main difference. You developing a prototype and you developing a product that is market ready. What does that life cycle look like? Right? We'll touch upon that in day number 2. Once you have that idea, once you have that understanding, from day number 3, we will start developing our power monitor. For that, we will first take an in-depth case study of the product development life cycle. So in day number 2, you got the overview. You understood the components, what you need to pay attention to. And then in day number 3, we will look at one end-to-end example of developing a product and putting that through the life cycle. What does it mean? What you need to be prepared for? And that we will do by using this wireless charging device, which is actually developed by one of our lecturers in this panel of lecturers, Isuru. We will walk you through that entire life cycle. So now by this point, you know what the product development life cycle is. You know one case study of end-to-end what you need to do. Now it is time for you to put the power monitor development through that same life cycle. So we'll start by giving you the requirements document, the BRD, the business requirements document, what exactly you need to develop. We will also give you the bill of materials. What are the electronic components required to develop this? We will tell you that. Then we will start with the conceptual model design, right? When we are giving the bill of materials, we will tell you, how did we choose the components? Why did you choose component A over component B? That is a very important aspect of the product development life cycle, because you just going somewhere and picking up the electronic component that you see first, that is not going to work. You need to study, you need to understand the requirement and choose things that are optimum for your particular requirement. So we'll cover that in day number 3. Once you have that information, in day number 4, we are going to start designing the schematic and the PCB. So we'll start on schematic design for microcontrollers using electronic design automation software. We'll be using KiCad. We'll touch upon the schematic design aspects. And in day number 5, we will convert that schematic into a PCB layout. Okay. Then you will have the first version of your PCB design, what it will look like when you print that on a board. Okay. We will also tell you how you can visualize that in 3D, visualize in the sense using 3D models of the components, how it will look like at the end of your development. We'll do that using Autodesk. Now, when we talk about the PCB, the first iteration of the PCB, it can have its own problems, right? Because it's the first iteration. In day number 6, what we are going to do is we are going to make sure that all the problems go away. For example, if you route a path on a PCB, we want to make sure that it complies with the standards. It can be safety, it can be electrical compliance. All these things we will have a look at in day number 6. So in day number 5, our focus is to get the thing working. In day number 6, we will make sure that we optimize it, we comply with the standards and the requirements. Okay. So under that, we will look at some advanced PCB layout design using some conceptual models. So there is one thing to keep in mind here. That is, when we give you the requirement for the project, we are going to give you the enclosure as well. Okay. And you might be thinking, okay, you guys are now teaching about embedded product design. And then in the outline, I showed you there are a few components about enclosure design as well. So if you are teaching how to design enclosures, why are you giving us the enclosure? Why can't we just come up with our own design? If you thought about that, that's a valid concern. The reason why we are giving you the enclosure design is because we wanted to make the smart plug look very nice. And that means we have actually taken some injection molded enclosures. So that hardware we will give to you. And you will be designing the PCB to match that. I don't know whether you know this, but if you go for an injection molding, the cost is going to be very high, in millions of rupees. So therefore, designing our own custom enclosure, injection molded enclosure, is not going to be possible. That is why we have given you the enclosure. So now your job is to understand the requirement and design the PCB such that it fits inside the enclosure. Typically in a product development process, this enclosure design and the PCB design, they go together, right? You do some initial work and then you might have to change it. That's how it works. But here we are fixing the enclosure and asking you to design the PCB according to that. But now if you're thinking, oh my God, my fun of designing an enclosure is now gone. Well, don't worry. The enclosure you will be designing will give you like the outcome and you will design that. We will teach you how to do a 3D print of that. So at some point, if you want to change the design for whatever reason, and you want to 3D print that as a prototype, then you can do it. Okay. But when we take this injection molding part, it looks very nice. It looks like a professional product. So then maybe you can even show that to your family members, look what I have done. It looks like something that you can purchase from a store. It looks very professional. The 3D printed one, on the other hand, it looks like a prototype. You will see the difference between the injection molded one and the 3D printed one. Okay. So your job will be to design the PCB to fit the given enclosure. And another reason why we did that is then you will be forced to optimize your PCB. Otherwise, you might even come up with a PCB that is this big. That is not the purpose. So it's not a commercializable thing. If your smart plug is huge and it does not look aesthetically pleasing, then that defeats one of the purposes of having a good product, right? So this added constraint will make your product look nice and will push you into developing an optimized electronic system, right? I hope that is clear. So the tools that you need to develop such an optimized product we'll cover in day number 6 in terms of PCB design, right? Now, at the end of day number 6, you have done something substantial and we'll give you that week and you will come back and give your designs to us. That is where in day number 7, we will have a PCB design review. We'll give you feedback based on what you have done, things that you need to change, how can we make things better. That is the focus of day number 7. Now, at the end of day number 7, you have a PCB, right? Then we need to send that PCB for fabrication. Okay. That fabrication sending part we will do in day number 8. Before that, we want to teach you how to develop the firmware for this. So the reason why we added this in day number 8, because then it gives you a little bit more time to work on the PCB before we send it to fabrication in day number 9 after the second design review session. Okay, so we give you some feedback, you make some modifications, and then you again come for day number 9, we give you some more feedback. Now we are ready to send it for fabrication. Okay, so we are iteratively developing the product with you. So this is another thing that we try to do, because typically, if you take like a course, a module in your university, what happens is you do a project and then you submit it, then you get a grade, right? You get a grade saying that, okay, you get a B for this, you get an A for this. That is how we are used to teaching. But when you look at the industry, is that really how things work? No, right? I hope you know. In the industry, you develop something and you work with a team to iteratively develop it. So now we have a fundamental problem or a difference between the way we are teaching and the way the practice of the industry. So this is another thing that we wanted to change in our courses, which is why we have multiple review sessions so that we iteratively improve with you. We believe that is the best way to learn. Okay, so that is why we have multiple design review sessions. We'll have another one. I'll come to that. But this is what we're going to cover in day number 9. Giving you time between day number 7, between the first review session and the second review session in day number 9. In day number 8, as I mentioned before, we are going to start teaching you the firmware development side. And also, we'll get started a little bit, a brief introduction about enclosure design using this Onshape. Onshape is a web-based tool that you can use to design enclosures. Right? So those two aspects we will get started. And we will also give you the enclosure here, the actual file. So then once you get the enclosure, you can actually see, you can load your PCB design into that and see whether your enclosure fits, whether your PCB fits inside the enclosure that you will put that inside, right? So once you check that, maybe you do some other modifications and after that you come for the second review session, you optimize it, you make some small changes, and now you are ready to send it to fabrication. Okay, so I hope up to day number 9 is clear. Then in day number 8, I told you that we are going to give you the enclosure. So by now you have done the PCB, you have an idea about firmware development. We got started and we got started on enclosure design as well. Day number 10, after we send it for fabrication, we will now continue our enclosure design. Because earlier we only got a small start, right? So now, how do we design something? Using Onshape, how to design the enclosure, we will teach you so that you can achieve the enclosure that we have given you by yourself, right? So when we give the enclosure, we are going to give you the final product. We are not going to give you the design files where you can change these things, and the design files you need to come up with. So we'll teach you how to do that. That is the focus of day number 10. Okay. So now you have done the enclosure as well. You will have some modifications to do in the future days as well, but majority of the work you have done. Coming to day number 11, we will tell you how to get started with PCB soldering and testing. What are the best practices? Once you get the PCB, you need to populate the components. So the components we will give you, you have the PCB, you have the components. How can you populate them and develop the end product of hardware? The skills that you need to do that, the PCB soldering and testing skills, we will cover in day number 11. We will also continue on our firmware development and testing part. Then how to program the boards using the programmer, we will cover. Moving on to day number 12. So here, earlier you started working on the enclosure, and I told you that if any one of you, because it's product development, you need to come up with your own product as well in the future. It might not be a power monitor. It can be something else. So if you need to prototype, you need to come up with an enclosure. So you designed it. How can you get it 3D printed? We will cover that in day number 12. We will have a design review session for your enclosure. What you have done well, what you have done wrong, then we'll fix them together. And then on the same day, we will tell you how to do the 3D printing, right? How to come up with that so that it is print ready. There are many 3D printing service providers in Sri Lanka. If you want to develop your own product, something else maybe, then these skills will be helpful for you. That is day number 12. Now, how many days do we have left? We have 4 days left until we get to day number 16. So in those days, we are going to wrap things up by connecting everything together. So far, we developed the PCB, we sent it for fabrication, we developed the firmware, we understood how to do the soldering and testing, we developed the enclosure. What is missing? The missing component is the cloud connectivity, as you can see, right? So starting day number 13, we'll complete our enclosure manufacturer discussion, and then also we'll start with our IoT component. Well, the cloud connectivity part of the IoT component will start in day number 13, and we'll continue in day number 14 and 15. So here, your smart power monitor will connect with the cloud, and we will develop the dashboard. This is the web development component that I was telling you about, but don't worry, you don't need to learn JavaScript to do this. It is a very simple, easy to use platform called Node-RED that you can have drag and drop components, and the code is automatically generated for you. And then you make some modifications to make it do what you want to do. Okay, so we'll teach you how to do that. Don't worry if you have zero experience on JavaScript, that is totally fine. This is a very easy to use platform. Some of you here, you have used it as we saw in the survey. Okay, so in day number 14, we'll develop the dashboard. In day number 15, we will connect things end to end, right? The entire software integration with the whole device working. We'll cover those skills in day number 15. Okay, so by the time you finish day number 15, you will have a working smart power monitor. The last day we are going to use so that you can come into the department for an in-person session. You will demonstrate your smart plugs, the working smart plugs, and we'll conclude the session. We'll talk about some future steps. What can you learn with what can you do with what you learn? We will cover. So that's it. That's what we are going to cover in 16 days as a part of the embedded product development for IoT course. Right. So I try to give you, try to connect the dots, how we have structured the entire course from the beginning until the end. Along the way, I showed you the logos of several tools that we'll be working on, the simulator platform, so that even if you don't have the components and the PCB ready, we can use this platform to develop the firmware, right? So you send it for fabrication. It can take like a month to get the PCBs from China. During that time, we'll use the simulator environment to develop the firmware. And once the components are ready, we put that into actual hardware. For that, we'll use the simulator environment. We'll use this platform also to draw the circuit diagrams. Then this is the PCB schematic and layout design software, VS Code for programming. This is the web dashboard platform, Node-RED. You can see it looks very nice. And these components are all pre-built. You can use them and customize them. Right? So it's a GUI-based platform. It will not be very hard for you to understand. This is our enclosure design software, OnShape. These are all web-based. Okay. Now, I told you that we'll be providing the required hardware for you. And in week number 2, we will give you details about the hardware that you need. And we'll also start forming the groups. The cost for hardware that comes in addition to the course fee, and we try to keep it to a minimum, which is why we placed a bulk order, and we can get the components for a very small fee. And we try to eliminate most of the shipping costs so that we can give that benefit to you as well. So therefore, we found people who are coming from different countries so that they can hand carry the components for you, right? So the shipping cost was waived, and between you and me, we did not have to pay any tax also, right? I mean, it's of course for educational purposes. We are not going to develop devices and put it out, but because we hand carried all those cost benefits, we try to give to the participants so that you can do it for a small amount, right? So the approximate cost will be about 4,500 for the hardware components per person. That is assuming that a group has 4 participants, right? So that one bulk of hardware to develop one power monitor, we assume that we'll be giving to 4 people in a group, and that is the per person cost. That includes all the electronic components, the plastic enclosure, the PCB manufacturing cost, and soldering cost, packaging and courier fee, everything, right? Yes, but if one of you think that, okay, we don't need the hardware that you are providing, we will get our own and work on it, for sure, you can do that, okay? So we will source the hardware and send you is what we're going to do. But if you want to do your own thing, then of course you can do that as well. I hope that part is clear. Right, then about the evaluations. So we are going to have 4 assignments, 2 group assignments and 2 individual assignments. These 4 assignments will be given throughout the course, and you need to complete all of them to get the certificate. Okay, we don't look at attendance. That is fine because we understand that you have your own commitments. So therefore, the sessions will be recorded and will be added on our online learning platform, and you can watch it later as well. But we expect you to complete the assignments. Even though I said attendance is not mandatory, we highly recommend you to come to the sessions, right? If you come, you can ask questions, and especially for the design review sessions that you cannot cover by watching a video lecture, right? So therefore, we highly encourage you to come. If you miss a session for whatever reason, the content will be available online. But a small piece of advice, if you decide to join the course and you think that, okay, I can cover this, like, you know, sometimes when we were in the university, we don't do anything for the entire semester. And during the last week of the exams, we try to memorize everything and then write a paper and get a grade. In this course, it is not going to work like that. Okay, so you need to continuously engage. So therefore, if you miss 1 week, please make sure you watch it as soon as possible and be ready for the upcoming session. Okay, so these are the assignments. We'll give you more details as we go into the course. You can see this, the flow is there. We'll first look at the layout design of the PCB, and then we'll have an assignment on firmware development. We'll have an assignment on enclosure, and we'll have an assignment on the end-to-end connectivity. Because we actually value the certificate that we give out of ENTC. We want to make sure that if we say someone is qualified to get this, the person has actually done it. Okay, so therefore, completing assignments is important. That is how we get the credibility as a department. When we issue something, a certificate, that carries a lot of value. So we want to make sure that it remains as it is. So please make sure you complete the assignments on time. You can work in a group, you can ask questions, you can come to the review sessions, get things clarified. All the help will be there, but you need to put in the effort and complete things with the help of us. Okay, so this is the panel of lecturers that will be covering the sessions that will deliver the content for you. So we worked as a team. We put in, as Kitmin was mentioning, we planned this course from last year. We did some initial discussions. We decided what project we are going to develop. Is it big enough? Is it small enough so that you can understand? All these discussions went in, and then we settled on this outline and the content. Right. So the lecturers have put in a lot of effort. I hope you will get the best out of it. So Kitmin, we have that talked to you before, Sanjula, Pasindu, Sachini, and Savindu, who are all graduates from ENTC, Tamidu, Pahan, and Chatuni, and Isuru, all graduates from ENTC. Isuru's project is that wireless charger that you saw. So we'll talk about that in day number 3. And we have the supervisors, Mr. Kosala that talked to you, myself, and Dr. Ranga as the head of the department. So this will be the team delivering the content for you. Right. So I think it's obvious to you that the course is designed to be outcome oriented. We of course teach you the fundamentals, and we combine that with real world applications. And the curriculum is custom made. It is not used anywhere. In fact, this particular curriculum is not even available for in the curriculum at ENTC right now. This course as a whole, the skills of this course is given through different modules, yes, but we custom made it so that anybody can understand. But please keep in mind, we expect you to know microcontroller programming, the basics, because we are unable to teach you how to do an LED blink in the course. So this is not for absolute beginners, right? This is for people at least who have done a small project, LED blink, some push buttons, something like that. We rely on that so that we can build on top of this. If you are an absolute beginner and if you still want to take the course, what we will do is we have some study materials that you can follow. We will make them available to you that covers the basics of microcontroller programming. So if that is the case, we'll provide. But please keep in mind, if you are an absolute beginner and you want to take the course, you will have to put in some effort to get the basics covered within these 8 weeks. Right? So a little bit of effort on your part is required if you are an absolute beginner. But as we saw from the survey that I asked you before, you guys already have almost everyone here, you have worked in one technology or the other. So that's good news. Okay. So we'll be building on top of that knowledge. Okay. We'll of course connect the dots because different people will be at different levels. We'll make sure that we get you guys up to the level of this. But if you are an absolute beginner, you have zero knowledge of microcontroller programming. We had a previous course, by the way. We had a previous course of microcontroller-based embedded system design through the same collaboration of ENTC and SkillSurf that covered the basics. So we assume this course to build on top of the first basic course. Okay, but it doesn't matter even if you have not taken the course. You might have obtained the knowledge from somewhere else, which is fine. Okay, so I think I talked for about 30 minutes. Before I move on to the other aspects, let me see whether we have some questions in the chat. I'll answer that and we'll get back to the slides. Otherwise, it becomes boring, just me speaking and you listening. So please keep the questions coming. I'll cover the questions in the Zoom chat. Then we'll get back to the last few slides of the presentation and then we'll go back to Mentimeter. Okay. Question. Is this course conducted online or physical? It will be conducted online. We will have the physical sessions and we will tell you when and where that is. Well, the where is obvious. It will be at ENTC at the University of Moratuwa. When, we will let you know. There will be definitely one session for the final day. Okay. Yes, Kitmin has already answered that question. Okay, question is, I'm a student, I'm studying electronics and CNC machining in Dreamspace Academy. What about payments for students? So we thought about this. Can we do something for the students? But because of the nature of the course, it's an advanced course. So the amount of effort and the time consumed is very significant from the lecturers. So therefore, it is going to be the same rate for everyone, right? So the first course, the basic course, we actually had a significant discount for the students. That is because then we already had some of the materials and we can deliver that to you. But this course, due to the nature of the course, unfortunately, we are unable to do that. Right? There is a partnership that SkillSurf has with IEEE. If you're an IEEE member, that comes with a discount. But for everybody else, it will be the same rate. Is possible to teach firmware development in ESP IDF using VS Code? Okay, Kitmin or anybody else, the person who is handling the last day. So we are going to use VS Code. The other IDs will also be using. Kitmin, is there anything for you to add to that question?
I'm not exactly sure what he means by ID.
Yeah, that's
he meant ID. Yes.
Yeah. ESP IDF is the question.
Maybe we can ask, revisit that question at Q&A.
Yes. Yeah. I'll get to that. We'll keep it for now. I'm not exactly sure what the question is. All right, Kitmin, you have already mentioned that. Okay. What is the URL for recording video? That question also I'm not very clear. So what we're going to do is this video we'll put that on YouTube and we'll be adding that on our website. So if you go to skillsurf.lk, I sent the link in the Zoom chat. If you go to skillsurf.lk tomorrow, so we'll try to set everything up within the day. If you go tomorrow morning, you will be able to see the recorded lecture available online. And that will be publicly visible. Anybody can see it. But the other videos, starting day number 2, that is going to be in Moodle, which is our learning management system. Moodle access will be given to everyone who enrolled in the course after the payment. Right? So we'll give you details to those who enroll after the payment. We will give that information. Okay. Another question, is there any WhatsApp group where we can form groups, or how can we contact other students? Yes. Once people have enrolled in the course before day number 2, we will be creating a WhatsApp group, and then after that you can form the groups. We'll give you details about that in day number 3 and 2. we can even set up like a Google form. If somebody does not have a group, you can submit the form and we will connect you. Right? We'll give you details about that. Okay. The Zoom questions are done, at least for now. So let me move forward in the presentation. Last few slides. This course we will be teaching that in English, and if somebody is having difficulty understanding, we will provide Sinhala and Tamil explanation. So please tell us that you did not understand something, and we will repeat. Okay. There will be time allocated for questions and answers, and if we feel like you guys are struggling, at least some of you, then we will have separate office hours where we will cover those things. We'll answer your questions. Okay. This will be the certificate that you will receive at the end of it. This is a dummy, by the way. On the right-hand side, you will see the content is not for this course. This is for the microcontroller-based embedded system design course that we did previously. But you will be receiving a certificate, something similar to this, given that you cover the evaluation criteria. Okay. So there are many things that you can do with what you learn. I think it's obvious, so I'm not going to go through this in detail. Now, coming to the question that some of you asked. Some of you asked that how can we form the groups? How can we gain access into Moodle? All of those things will happen from day 2 onwards. And please make sure, so based on the introduction that you received today, if you think it's a worthwhile investment for you, it's a worthwhile investment in terms of your money and also in terms of time, you can enroll. Please make sure you do that by next Wednesday, because then that will give us enough time to send out all the information to everyone, prepare how many people are taking the course, and then we can start day 2 from next weekend. Okay, so what you need to do is, please go to this link, bit.ly. This is a bit link, ENTC Embedded Product Design for IoT. We'll send the link also. And in the text messages we sent you and also in the emails, we made it very clear. So this is the website. If you go there, let me go to the website and show you. Give me a second. Okay, here it is. So this is skillsurf.lk. You go there, and then if you click on view details, how to join, all the details are here. Okay, so it's the same email that we sent to everyone. We added that as a document to the website. Okay. So what you need to do is, you need to follow the instructions in this document. It's 2 pages. Please make sure you read everything. And there is a terms and conditions document as well. Please make sure you read everything, and then you submit this Google form if you are enrolling in the course. Okay, so that's what you need to do before 7th June, that is coming Wednesday. There are multiple options to make payments also. So depending on which one you are comfortable with, you can do that. But please make sure you follow the instructions. In the past, there have been instances where people do not follow the instructions, and then after that, it is trouble for everyone. So please don't do that. The instructions are there for a reason. Please make sure you follow them. Okay. I'll go back to the slides. Right. So the course completion requirement is you must complete the evaluation criteria
Dr. Subodha will join soon. I think he's having some technical issues.
Hello guys, can you hear me?
Yes.
Okay, so my laptop decided to get stuck all of a sudden. I'm connected to Zoom, but it's not allowing me to do anything. Please bear with me. I quickly connected through my mobile. I'll fix this and we'll restart the presentation. I'm really sorry for the inconvenience. Sometimes every other application I can work on, but not Zoom. Zoom does weird things sometimes. Let's see. Kitmin, at what point did I get stuck?
I think you are covering the payment methods, and then maybe the slide after that.
Okay, right. Let me restart Zoom, and then I'll be able to continue. Please give me a few minutes. I'll be back as soon as possible. Kitmin, shall we answer some questions in the meantime? Maybe you can go to Mentimeter
Sure.
and yeah, let's do that. Otherwise, you're wasting people's time. Yes.
Okay. Let me go into Mentimeter. Okay, I can see some questions. Okay. Let me share my screen. So yeah, I think yeah, we can see the questions now. Okay, I think this question was answered by Dr. Subodha. Yes, we will be uploading to the website, and you can expect an email as well with the registration details. So maybe we didn't include this in our business requirements document. I think we wanted to develop a specific kind of a product, but definitely we can discuss this during the project overview, why it was not included. So far we have like specified what kind of a product we're developing, and we've done a business requirement document for that, and we're developing that product. So it's based on what the specifications or the requirements for developing the product, or you can't put all the functionality you want in a single product.
Yeah, Kitmin, it might be helpful because if somebody is not looking at the screen, let's read the question also. Then they have the context.
Oh, sure. Okay. Is there any discount in course fees for the students? I think this was also answered by Dr. Subodha.
We covered that, yes.
Is power factor considered in this smart plug implementation? Not 100% sure what power factor implies.
Well,
I'll skip this question.
If the person is referring to like the power factor correction, the phase difference basically between reactive and active power, that is like an enhanced thing. Well, you can think of it in terms of if you have like a kVA charge in your appliance, that can be helpful from a business perspective. But this was not one of the focuses when we were designing the requirements. So this will not be a priority for us. We will not be making any, like typically you like put like capacitor banks and all that to correct the power factor. If that what the question refers to, that will not be a focus of us for this course.
Okay. Is all the content covered based on the smart plug only? Not necessarily. It's kind of general content, but the smart plug is kind of the focusing project because we are trying to use an example to explain everything, but all the content is still general content that you can port or you can use for your own work as well. So I wouldn't say it's based on the smart plug only, but it's definitely content that we it's the step-by-step process that we have developed that was useful for developing the smart plug. Hope that answers the question. It's so the course is based on like a inverted learning approach. You want to build something, you understand what you need to do to build it, and then from that you approach it. Is it possible? Okay, I think this was the question in the chat, and I have checked with the lecturers about ESP IDF. Necessarily, since we're using WOCV, we don't probably need a separate framework, but we'll look into that. Not enrolled to this course, have I? Oh yeah, we'll share with these details. Will this course be the same as? No, this is not the same course. You will get some videos to look at the content of the 2022 design course, but this is the advanced version. So this is about product design, not embedded system design. Yes. I am a final year student. Currently, I'm working on my final year project. Do you think I'll be able to do this? So you have 3 months of commitment, roughly speaking, for this course. You are free to like review all the documents you'll be getting before registration. But if you have the flexibility to manage all the assignments, I think you can, and it's a group-based work this time. So if you can actually manage that amount of work, I think it should be possible. There's a large space, the time duration we are giving for assignments, and it's very laid out, not compacted like the embedded course. So I think it's something you can consider.
Kevin, sorry for interrupting. I can
yes.
share my screen again. We'll come back to the questions again.
Okay. I think there's 4 more questions left.
Yes.
Sure.
Yeah. So we had a small commercial break, courtesy of my Zoom getting stuck. But I hope I was here. I believe so. But anyway, if it's a little bit of repetition, please bear with me. So to obtain the certificate that we showed you earlier, you must complete the evaluation criteria, but the attendance will not be taken. The course material will be available through Moodle, that is our learning management system. All the communication will happen via email as well as through the WhatsApp group. Just a quick check because I got stuck earlier. You can hear me clearly now and you can see the screen also, right?
Yes.
Perfect. Thank you. Okay. For details, please always refer to the website and the details. The WhatsApp group will be formed once enrollment is done. That will happen within the coming week. Then I wanted to like conclude the presentation with a few things. This is, I think, where I got stuck. Lessons learned and steps taken. So what does it mean? Let me go back to the website and show that to you. Some of you might know this. This is not the first course we are doing. So we have been doing courses for about 2 years now. We first started with this course, microcontroller-based embedded system design. Started in 2021, actually, around that time. And then we had the second iteration of this course, microcontroller-based system design, last year. That was around October last year. Then we also touched upon things like quantum computing, about system Verilog, right? These courses were conducted in the past. The most recently concluded course was the System Verilog one. This is related to computer architecture. Our motivation behind delivering these courses is to create a workforce that are proficient in these 3 focus areas: Internet of Things, computer architecture, and cybersecurity, which is we are yet to get started. We are making plans for that right now. Under these focus areas, we have been doing the courses that I showed you before. Now the first course of the IoT focus area is this one, the microcontroller based embedded system design, the very basic course where we start from blinking and LED. Then the second course of the series is this one, the one that you are here for right now. This is why we assume the basic knowledge of electronics. And the third course in the sequence is this embedded machine learning for edge computing. We had one iteration of this, and we are planning to have the next intake towards the end of this year. So this July, we were initially planning for that, but on the website, this needs to be updated. We will not be doing that because even this course goes until August. So we'll prepare the plans for that and we will let you know, but that is going to be the third course of the IoT focus area. The other focus area is computer architecture. As I mentioned earlier, the system Verilog course, we started this focus area earlier this year. So the first course we completed a few months ago, right? So as you can see, this IoT based, the product design course is not the first course we are doing. We have done courses in the past and we have learned from the feedback that we received from the participants. In this slide, I'm summarizing a few feedback that we got and the actions that we have taken to address them. We believe that is important because now it is something that we keep on saying. In education, typically in a university, what happens is, if you are the student, you come to the university and you learn. The university is the service provider, right? The university is the place which provides the service to the students. But for whatever reason, education is structured in a way such that the service provider is the one evaluating the client, the student. One can argue that this is inevitable, but through the courses that we are offering to the public, we want to make sure that the service provider is evaluated as well. That is how we sustain, and that will push us to get better. So in the first few courses that we developed, we gathered the feedback that we received. So it's a summary. For example, here, some students needed extra help to follow the material. So we have understood that, which is why I mentioned that if you have any issues, we'll provide study materials, we'll have separate office hours. And in the System Verilog course, the one that concluded recently, we even had a separate WhatsApp group for the beginners. So they can send messages to the group and one of the lecturers will answer that. That is another extra step that we took to help the students who are struggling, right? Then in one of our previous courses, the certificate got delayed to be sent out. That happened because once you complete the assignments, we need to grade the assignments. And once grading is done, we need to send like the list of names through the university, through multiple layers to get approval for the certificates. But now we have worked with the administration and we have shortened the approval process so that we can send the certificates soon. Right? So that is one shortcoming that we had in the past that we have rectified now. And another comment that we received is that a lot of topics are covered in a short period, and it was too much to understand. For example, in the first offering of the embedded system course, the microcontroller based embedded system design course, we did two projects. The first project was a Medibox, and the second project was another small IoT device. Then students gave us the feedback that it was difficult for them to cover two projects within eight weeks. And we understood that, which is why through the product development course, we are doing one project that covers all the skills. We actually used that same feedback, and when we were doing the second iteration of the microcontroller based embedded systems product, we did only one project, and that covered the entire scope, right? So we go into detail of one project. We have case studies and working sessions to make sure you're comfortable with it. And we also offer additional study materials for later and for you to refer later. This is another reason why we added the buffer weeks in between, right? So you have time, some time when you work on it to refine it, to work as a group. That is why we have the buffer weeks. Earlier, we had like 8 weeks back to back. We were thinking that it is better for people to complete this because they have other commitments and move on. But now we understand that, okay, having some buffer in the middle is good. So even though we are covering 16 days, that is 8 weeks, the course spans for about 3 months with the buffer weeks. Okay, so that was the motivation, to give you more time to work. Of course, we cannot make everyone happy. There will be some people saying that if we can finish this earlier, that is good. But an overwhelming majority of you said that you need time. So therefore, we added the buffer weeks in the middle. So these are some of the feedback, and this is a summary, as I was telling you. And this is one negative feedback that we got, because the person was saying that it was a lot to digest, not happy, can be improved. So these are some initial feedback that we received. Therefore, we have improved our work based on this. Out of about 200 people who took the System Verilog course, which was the most recent one, about 90%, 90 to 95% of them had like 5-star ratings on the course, and only about 5 to 7% gave some negative feedback, which of course we'll use to improve. But now we are happy to say that we have come to the point over 2 years of time where we have done many things to improve ourselves, and we want to make sure that we deliver a good service to our clients, which is you. Just like we evaluating you through the assignments, you can evaluate us. We are mindful about that, which is why we are taking this feedback into consideration. Right, so that's it. Oh, by the way, I told you about the negative comments. We had a lot of positive comments also. So here is one. I'll not go into details about this. Let me take time to answer the other questions on Mentimeter, and I will make the good comments appear here so you can read them in the meantime. Okay, okay. A few questions coming in Zoom. Okay, right, so the ESP IDF question, I believe, has been sorted. Yes, so that Kitmin has replied to everyone, so I hope that is clear. Do we have any other questions on Mentimeter? I believe we do. I'll keep this screen shared, Kitmin. If you can like read out the question, then
sure.
we can answer.
So there's a few more questions. I think there's 7 more questions here. What kind of microcontroller are we going to use for this project? So it's going to be the ESP32 chip this time, not the board. I think this was something we received in the feedback of our previous courses, since we used the ESP32 board in the Smart Medi box. So this time we are designing using SMD components, and it's the ESP32 chip that we are going to use in the PCB layout. Next question. Are we going to use C++? Yes, we'll be using C++, and we'll also be providing the C++ introduction to C++, usually done by Barajitan. He's not involved in this course, but his video, we can provide it to everyone as a learning resource. Is a new registration possible? Yes, you can register from today onwards. Once the information is provided, you can register for the course. What is the CAD modeling software that is going to, so it's OnShape that we're going to use. And yes, we'll be, he's asking whether we can provide short videos of the previous courses. So we've already prepared the videos. We'll be providing them in the online, like on Moodle, we'll be providing them. What are the measuring parameters in this project? Measuring parameters. I think in the business requirements document, you will have all the information you need. So I think measuring parameters as in what this device is designed for, and what the sensor readings are indicating, what we're displaying on the IoT dashboard, all these things will be the business requirements document. Can you share the course curriculum, Dr. Subodha? Yes, we'll be sharing this curriculum in the guidelines document so that you can go through it, and we'll also be posting this video on the website so you can look at that curriculum. What is the value in the field for the certificate issued at the end?
Yeah, so the certificate will
yes.
actually provide evidence to the fact that you have covered this material. That is our purpose. So if you notice the certificate outline that we showed you, let me go back to that. It's going to be two-sided. The first side is like the the typical certificate layout, and the other side covers the outline that we have that you have completed in the course, right? So that provides a testament to the capabilities that you acquired, and how to use that. It's really up to you to decide if you want to use that, maybe to get a promotion or maybe to even get a new job. The fact that you know these things, that is the purpose of issuing the certificate, and you will be the best judges of this. As ENTC, as University of Moratuwa, there is value to the certificate that our university and the department offers. So therefore, we hope that will give you a good credential by the time you complete the certificate, complete the course. Of course, the skills is what matters. The certificate is just one piece of evidence you can show. If you can get the work done, the certificate might not even matter. Right? If you can do things, nobody is going to come and say, okay, I understand that you can do it, but do you have a certificate? That rarely happens in the industry. If you can do things, then yes. But for the purpose of getting a new job, maybe to show that you know these things, the certificate can be helpful. That was the purpose. So the outline will be here. I hope that is clear. I hope you answered. Kitmin?
Yes. Yeah. Thank you for that answer. Definitely in the interview, being able to answer an interview question depends on your skill, but getting into the interview depends on the recognition of that skill. So a certificate would probably help there. This is the last question I'm seeing. What are the programming languages that we are going to use in this project? Since it's a product design course, it's not necessarily about the programming languages that you're learning, but if I think about it like C++, JavaScript, and maybe a bit of Python, MQTT protocol, that sort of stuff will also be involved. Yeah, I think that's pretty much it. Programming languages wise, that's what I think we should highlight.
Right.
Yeah, I think that's all the questions.
Yes, I got a few direct questions. Kitmin, one person asked, how can he or she, the person who asked the question, learn Java and Python? That is actually beyond the scope of this course. We are not providing that information to you through this course, but we can, anybody has any doubts about how to learn a new technology, the panel of lecturers here, they have gone through this similar languages. So we'll be happy to provide you those resources. We can do that. But Java and Python for the purpose of this course will not be useful. Then another question that I got as a direct question to me on Zoom, are you conducting this course next year as well? That remains to be seen. We definitely will have a repetition, but whether that will come in next year or the year after, we are not exactly sure. Because right now the motivation or the structure that we have in mind is to provide the basic courses at a higher frequency. So more and more people get the basic knowledge, and the intermediate and the advanced courses at a lesser frequency, because let's say you have 2 batches coming out of one basic course, those 2 batches can get fed into the advanced course, because it will be a subset of the people who did the basic course who will be getting who will be willing to do the advanced course, unless they have taken that knowledge from somewhere else. So due to that reasoning, we'll have a lesser frequency for the intermediate and the advanced courses given through SkillSurf. The basic courses will definitely be offered every year. So you take the microcontroller based embedded system course, that will be repeated every year. Okay. Could we get career guidance for finding jobs in industry? Well, we already have people from the industry taking part in the course. Mr. Kosala was here, so his company is doing product development. If you perform exceptionally well, he might, this is not a promise, okay? Yeah, Mr. Kosala didn't tell us anything like that. He did not make any promise, but the industry is there. Then, of course, the industry is looking to hire people, as you can see. Right now, some people say that there is no electronic industry in the country. The problem that is faced by the industry is not a lack of opportunities. Let me emphasize that. The problem faced by the industry is not a lack of things to do. It's not a lack of opportunities. It is a lack of skilled people who are capable of doing these things, right? So we will of course tell you how you can approach. We can give you guidance, but we are not promising jobs through this course. In the future, we have a plan where we get a commitment from the industry to interview the people who do exceptionally well in our courses. But as you can see, through the ENTC and SkillSurf collaboration, we are developing our portfolio of courses right now. So once we have a substantial number of courses and a substantial number of people taking those courses, then we have future plans of doing that. But we don't have that infrastructure right now. We can give you guidance based on the knowledge that you have, that we have, but there is no guarantee that we are going to get you a job. We can't do that. We get the skills, we give you the skills, we tell you what you can do with this, we give you general guidance, and then it is up to you to decide what to do with it. Okay. Yes. To the question, career guidance, yes, that we can provide. Okay. I'm just scrolling through the chat to make sure we did not miss anything. There is one more question. Is a new registration possible? My friend also like to enroll. Yes, new registrations are possible. So we gather the registration so that we can inform you guys when we are starting the course. But we will consider you as an enrolled participant if you go through the instructions on the website, you make the payment and you submit the Google form. Right, so let me quickly show that to you again. You go to skillsurf.lk, you go inside this program details for this course, and you will see this link, view details on how to join. So click on that. The instructions are there, what to do. And the people who submit this enrollment form, the one over here, that is the group of people that we consider to be enrolled, and that is the group of people who will continue forward from day 2 onwards. Right, so yes, a new person who did not register can enroll in the course, which is why we are making this video, the recorded video, public, and this website, the information here is also public. So anybody can join as long as they complete the requirement before the deadline. Okay. Kitmin, do we have anything else on Mentimeter?
I think okay.
Nothing new coming, right?
Yes.
Let me
Yeah.
quickly check that also. Yeah, so from our side, we tried to order the components in advance because, as you know, there are some limitations in the global supply chain in terms of electronic components, because we recently tried to purchase some Raspberry Pis for another reason, and it was very difficult to get them. There are huge lead times, people cannot get them, so therefore we thought, okay, we'll do it soon, have everything ready so that we will not face any difficulties once we start the course. Yeah. So it's just checking Mentimeter. We had 19 questions. Kitmin, I believe we answered all of them.
Yes, I can confirm 19 questions answered. Yeah.
Yeah. Okay. Then I believe everyone is clear about what we are going to cover in the course, and if they want to continue, what they need to do. Shall we wrap it up then? We said 10 to 2, but of course we don't need 4 hours for this. Maybe we can give some time, allow people to have some early lunch.
Yeah, sounds good.
And let Kitmin sleep early. All right, then so we're actually glad that we got about 80 people joining today. We are happy to see this many people interested in the course. We hope to see the same enthusiasm from day 2 onwards as well. So our promise is to deliver an impactful course and to make sure that you learn these things and you can effectively contribute to your company or for your own product development in the future. So that is the commitment from our side. With that, it is up to you to decide whether it's a worthwhile investment of your money and time. Okay, so we look forward to see many people out of here from day 2 onwards. Please follow the instructions on the website. Thank you very much for your enthusiasm today, and a huge thank goes to Dr. Ranga, to Mr. Kosala Jayasundara, and also the entire panel of lecturers for putting in an extraordinary amount of time and effort to deliver an impactful course. So we hope you will reap the benefits out of the efforts that all those people put in. Looking forward to see you in day 2. Have a good rest of your weekend. We'll see you in next weekend. Thank you very much.